So good day. So in this lecture, we will be discussing about the skeletal-muscular system. So the skeletal-muscular system is a multifunctional and a dynamic system. So the movement. So basically, the skeletal-muscular system is its most important function is locomotion, enabling movement. So movement is a defining characteristics of animal life. Basically, animals can move around, walk around, crawl, climb trees, etc. Whereas the flora, that is the plant life, they are static, they grow. Well, it's not that the plants cannot really move, but they are stationary. But animals can move from place to place. So for the humans move by applying tension to the bones and joints of the skeletal system. So basically, the musculoskeletal system walks hand in hand to actually move or walk. So for example, how do you lift your arm? So you have the movement is initiated by of course, the stimulus from the neurons, but then the muscles contract, the contraction of the muscle pulls the bones. The bones, basically. For example, your arm, you are flexing your arm, so it pulls the bones in your arms towards. Of course, the muscles can only pull, not push. So it pulls the bones, and so your arm moves. So the tension is applied by the skeletal and basically this is the muscular tissue. The skeletal and muscular systems work as a cooperative unit. So the skeletal muscles are connected to the bones, and so when the muscle contracts, so it pulls the bone and causes it to move. So that's it. So basically, the movement and the locomotion. So what are the key functions of your skeletal-muscular system? So you have movement and locomotion. Aside from that, it also protects the organs in the thoracic and abdominopelvic cavities. Basically, the organs in your thoracic cavity, these are the very important ones. The heart, of course, and the lungs. So they are protected by your rib cage, and of course the pectoral muscles and the intercostal muscles. Now for your abdominopelvic cavities, for the pelvic cavities, it's in the hip bones. So the hip bones provide some protection to your to some of the organs in your pelvic side, but the abdomens are usually protected by your abdominal muscles. So aside from that, it also helps maintain homeostasis, especially in the maintenance of the temperature. So it maintains muscles, specifically the muscles. They help maintain internal heat. So the contractions of the muscles, it's a metabolic activity. So it generates heat due to chemical reactions. And for humans, it helps us maintain an upright posture and a bipedalism. That means we can stand upright in 2 feet. So it helps in manipulating the environment. Of course, we can actually move things around. So in addition, the skeleton, it helps produce the blood cells. Basically, our red blood cells are produced in the bone marrow of our long bones. So it also stores and releases minerals such as calcium and phosphorus. Our bones are healthy and strong if it's rich in calcium deposits. Basically, the bones are our calcium and phosphorus bank. It's our mineral bank. So if you are rich in calcium and phosphorus, you have a healthy bank account. So you have your healthy bones. So if you are deficient in calcium and phosphorus, your bones are brittle, because just like what a bank account is. So if you are a one-day millionaire, your bank account is unhealthy, so it can easily fracture or collapse. So calcium is also required. It's a very important mineral. So it's required for skeletal muscle contractions, and thus there's a vast calcium store ready for the skeletal muscles to tap directly, since our muscles lie directly next to your bones. So if you are a very active person, you must intake a lot of calcium. Okay, so, because of course you're always using your muscles. Aside from that, you must maintain strong bones, especially if you're an athlete or into sports. So the skeletal-muscular system is vital to the survival of us. So here is a figure how human life. This is the the diagram of the different species of the humanoid species. So even though we have many modern advances to ensure food and safety, our skeletal and muscular systems are still needed for our daily survival. So the skeleton holds the body together while the muscle provides the movement. So basically, that's the dynamic between the skeleton and the muscles. That is also the reason why we are not discussing skeletal system and a muscular system separately. We are discussing them as a one unit because they work together as a unit. So the bones and the muscle work together to meet the internal and external demands of the body. So both are made of a living tissue, but they cannot work separate from each other. So remember, if you imagine, if you have only muscles without the bones, your muscles can contract, but then so what? You cannot really move without. What's the use of contracting if there's it's not doing anything or not pulling anything at all? Aside from that, the bones provide the structural framework of us. So if it's not if it's just purely muscles, so we really cannot stand on muscle alone. We need to have a support, haligi, a structural support for us to actually move. So movement is possible because of this unique arrangement of muscle and bone. So the muscles and the bones are held together. The bones are held together by the joints, most of which permit movement between the bones. So putting on one bone by muscle causes movement of the accompanying joints. For example, flexing your arm, the joint in question here that's moving is your elbow joint. So all human skeletal muscles have similar function and structure. So they contract. So the contractions makes the muscle shorter. So by getting shorter, of course, it pulls on the bones because that muscle is connected via the tendons to the bones. So by the way, the tendons connect the muscle to the bone. The ligaments connect the bone to other bones. So muscles can relax to their original or resting length afterwards, but they cannot push. They just relax. So for example, if you are flexing your arm up or moving your arm up and down, so there is that movement is actually facilitated by more than one muscles. So most of the time muscles work in tandem with one another. So one is pulling, and then if you are moving in the other direction, another muscle partnering that muscle, the first muscle in question, is doing the contracting. For example, the biceps and the triceps. So if you are flexing your arm, your biceps contract. Your triceps, that's the one on the underside of your arm, relaxes. So the movement is that you are folding. Basically, you are pulling your hands toward yourself. Now, if you're extending your arm, so the biceps are now relaxing, and that the triceps are the one that are contracting. So the effect is the opposite. So the movement is reversed. So basically, muscles tend to work in groups to actually provide adequate movement. Muscle is very difficult for just only one muscle to move. So it's usually in tandem with actually they usually work in teams. So for the bones, the bone is a strong and light tissue. So we have a compact bone, which is the dense one. So this usually occurs on the outer edges of the bones and is composed of many individual osteons. So what are those osteons? Osteons are concentric rings of the bone matrix laid by osteocytes. Osteocytes are the bone cells. So the bone matrix consists of minerals, which is your calcium and phosphate. So basically, that's why it's called the bank. So your osteoblast basically builds up the matrix using calcium and phosphate. That's why they are compact, they are dense, and they are strong. So the bone matrix also contains collagen fibers. So the collagen become mineralized, which turns them solid and firm. Collagen is basically a protein molecule. So they are structural protein molecules, and when they become mineralized, that means the calcium, the minerals, the calcium and the phosphates are being deposited in this collagen matrix. So that's why this collagen matrix become more firm and solid, more dense. So this is in contrast to the collagen fibers found in other connective tissues, which remains flexible. So even in our skin is supple. Well, at least for the young people, the skin is mostly supple because of the collagen fibers, but they don't become hard, they don't become mineralized. The collagen at the bones, related to the bones, are the ones that are being mineralized. Anyway, for the spongy bone, they usually form within the deeper portion of the bone and provides inner support. So the spongy bone is porous, it's less organized than the compact bone, and they lack osteons. So the spongy bone has the trabeculae, or the struts, that form in response to the stress. So if you imagine building, remember, for if you're building a house, for example, the roof of the house has struts there, and even in the important foundations, you have the struts to help provide structural support. So the same goes for your bones. So this is the trabeculae in the spongy bone. So they have struts there. So the trabeculae are composed of your osteocytes. So this is the structure of your bone. So this is basically just one-fourth view, cross-sectional and lengthwise view. So you have this compact bone area or region here, composed of the circular osteons. So within these osteons are your nerve and artery, blood vessels. So you have your different canals. So this of course, since they have cells here, of course, they must be supplied with nutrients and oxygen. That's why you have blood vessels passing through these osteons. And then this is the spongy bone. So if you notice, they are not compact. The spongy bone is not compact, but rather you have it's like a cross section, or no, not a cross hatch of different somewhat like webbing. So these are the struts. So these are the trabeculae. Now you have your so you have these lymphatic vessels and the different blood vessels. And this is the canaliculi. So this is your osteocytes and your canaliculi. So they are very small. Well, canaliculi, so called canaliculi because they're like small canals. So you have a central canal and then canaliculi. So what are these? These are your cells, the osteocytes there. Now, let's look closely at the osteon. So the osteon is a concentric rings of the bone matrix. So the center of each osteon is a central canal called the Havesian canal. So this is where the blood and the nerve supply is usually located. So the bone matrix is formed by the osteoblasts and maintained by osteocytes. So for the bones, for the bone cells, the osteoblasts are the building up, the cells that build up the bone. So basically, they are the ones to create the matrix. They are the ones that build up or mineralizes, input calcium and phosphate to the matrix for the bone to become more mineralized. So the osteocytes live in the lacunae, or the small lakes, so-called lakes, which are because there are small holes in the bone matrix. So the canaliculi, or the tiny canals, extend between each lacuna, which contain nutrient fluids. So they serve as, of course, they are the ones that supply nutrients, oxygen to the osteocytes in each lacunae. So materials passes to and between osteocytes in the lacunas. It flows through the canaliculi. Because remember, these are dense, they are compact. So you need to have the canaliculi for the different osteocytes to receive their supply of nutrients. So perforating canals connect several central canals together to allow for communication. So the formation of the bones. So the bones are formed of connective tissue produced by the immature bone cells called these osteoblasts. So ossification, or known as the bone formation, they occur in two ways. You have endochondral and intramembranous. So endochondral ossification, endo means inside, chondral, basically it refers to cartilage. So this is the usual way how bones form. Basically, you form first the cartilage and the bone is formed within the cartilage. Whereas the intramembranous ossification are the usual way of formation for the flat bones of the skull, the clavicle, and the mandible. Now, this is your endochondral ossification. So you first have your cartilage, and then this matrix becomes this is your cartilage. Your cartilage will form your matrix that will have a nutrient supply of your arteries, and then the ones that supply once you have a steady more steadier supply, so you have the mineralization part of your brain. Sorry, not the brain, the bone. Okay, so development of the secondary ossification center. So basically, this usually when you're a child, most of your bones are cartilaginous, so they're soft. So as you grow older, the minerals are being deposited to these bones, and of course it gradually becomes ossified or mineralized. They become bone. The cartilage become the bone. So this is your bone formation. So bones grow longer and thicker. So growth occurs at the outer surface of your bone. So cells within the periosteum, which is the membrane that covers the bone, are differentiate into the osteoblast. So this is during formations, development of the fetal development. So the accumulating matrix entraps the osteoblast. So the top osteoblasts mature into osteocytes, and the osteocytes maintain the structure of the bone. So looking at the parts of the long bone, actually I won't delve too much on the bone anatomy. I'll be focusing more on the movement side. But anyway, how the long bones are basically, they are, of course, long, elongated. So you have a diaphysis forms the shaft of the bone, and the epiphysis, basically the diaphysis is the long part, and the epiphysis are the ends of the bone. Okay, and then at the ends of the bone, you have your layer of cartilage. So this thin layer of cartilage prevents the bones from grinding one another in the joint, and that's why arthritis is a problem for old ones, because the cartilage becomes worn down, and so without the cushion, the cartilage cushion, the bones then grind one another, and that is painful. Because remember, our bones still have the nerve endings, and of course, when you are grinding the two bones together, I mean, imagine the pain. So you have that part of your long bones. So the cartilage protect the ends, the epiphyseal parts, the epiphyses, especially in the joints, usually found the cartilages there. So it helps cushion the bone, as well as lubricates them. It prevents them from grinding one another. So bones constantly undergoes remodeling and repair. So we have the osteoblast that builds up the bone, and then we also have the osteoclast. So this is for the bone remodeling. So the osteoclast are the large cells that release digestive enzymes and acids that break down the bone matrix and release calcium and other minerals into the blood. So again, it comes down to homeostasis. So remember, the bone is the bank. It's not it's not a one-way bank. It's actually a two-way bank. So when I say two-way, you can deposit and you can withdraw. So if you need calcium, you withdraw calcium from your bones. So, and how do you withdraw that? The osteoclasts break down the bone matrix to release the stored calcium there. So bone repair is a drastic version of remodeling. So if you have fractures, if you experience fractures, of course, you have bone healing. So for the bones to heal, that's why you need a cast, because you want your bone to align properly, and then allow the osteoblast to build up, or to heal the break or the fracture in that bone. So close reduction is when alignment is possible without disturbing the skin, and you have open reduction when the skin must be cut. And of course, you need to fix the bones in place, and usually done by utilizing metal screw, and this is usually seen in compound fractures. So that's why for fractures, you need to immobilize the bone for them to heal properly. Now, looking at the skeleton, so we can differentiate the skeletal system, the bones, into the axial and the appendicular skeleton. So the axial skeleton are formed by the central axis of the body, basically your skull, the rib cage, and the spinal column. And then the appendicular are your limbs. So your shoulder blades, your the arms, and the legs. Okay, so and then also the pelvic girdle. This is your hip bones. And then classification of the bone. So long bones are longer than longer than they are wide, whereas short bones, they have a rather more irregular shape. So you have short bones that in the wrist, the short bones are more rather irregular but usually cuboidal. And then we have flat bones, very thin in one dimension. So what are examples of those flat bones? You look at your shoulder blades, so they are flat bones. So the sesamoid bones are the bones that form inside the tendons. You have the patella, the kneecap, and humans can gain additional sesamoid bones due to stress put on bodies, such as wearing high heels. So this is due to the ossification of some cartilage. Now, we also have irregular bones that have odd shape. So what are examples of that? So we can have the bones in basically the rib cage. They have a rather irregular shape. Wormian bones are embedded in the sutures between the main skull bones and are not found in everyone and not part of the 206 bones of the skeleton. So these are bones usually in the skull area. So the axial skeleton is at the center of things. So we have 8 cranial bones held together by sutures, and this one protects the brain. We have 14 facial bones, which helps give identity. The face. So sometimes if you tend to watch the top America's Next Top Model or any other top model story, they always talk about they have a good bones, etc. So it talks about the facial bones because it's, of course, again, the bones is where our muscle tissues are attached to, and of course the skeleton has the facial bones per se have a say or significantly affects our facial structure. And then we have the hyoid bone. Hyoid bone is a floating bone, so it's not attached to any other bone of the body. So unlike the other bones that are usually attached to one another, so they are floating. We have the 24 ribs that protects our organs in the thoracic cavity and work with the vertebra for the posture. And of course, we have the 24 vertebra. So 24 ribs for the 24 vertebra. So the ribs are attached to the vertebra. And then we have the sacrum, which is made up of the 5 fused vertebral bone and 1 coccyx, which is around 3 to 5 of the fused vertebral bones. So the vertebral column provides the upright posture and protection of the spinal cord. For the cranial bones, we have the parietal. Basically, the cranial bones are usually paired. So the parietal bones and the temporal bones are paired. You have the left and right temporal, left and right parietal bones. Then we have the frontal bones that protects the forehead, the frontal lobe of the brain, the occipital at the back, ethmoid and sphenoid bones. So aside from that, I won't be really delved too much again on the anatomy of this bone. So you have the facial bones. So you have the vomer, the mandible, the maxillae, and the palatine. So the maxillae and the palatine are paired. So they form the palate, the mouth. The palate of the mouth. You have the nasal bones, the lacrimal bones on the side of the nose. Lacrimal because basically, lacrima means tear. So, tear as in the tears. So you have basically, it's not where the tears come from, but rather this one is more in support of the around the area of the eyes, around the area of the tear glands. So we have the zygomatic bones, and then you have the inferior nasal concave. So these are your cranial and the facial bones. And then you have the vertebra, the ribs, and the axial skeleton. So the vertebral body, we have the vertebra, which consists of the 3 parts: the vertebral body, which supports the weight of our body; the vertebral arc, which usually form your which also has the foramen, which houses the spinal cord, and your articular processes. So basically, because the vertebra not only supports our body but also protects the spinal cord, and as actually it's curved. So you have a curve. Our vertebrae are usually curved. So we classify them. The 24 vertebral bones are classified: the cervical, the thoracic, the lumbar, the sacral, and the coccyx. So they usually have different shapes as you go down the vertebra. Okay, so let's look at osteoporosis. Osteoporosis is a progressive bone disease resulting from an imbalance of calcium homeostasis. So remember, our bone is our calcium bank account. So it specifically attacks the axial skeleton and causes the bones to be fragile and unable to support the weight of the torso. The dowager's hump is caused by a painful vertebral fractures that reduce the height by several inches. So hip fractures are largely due to osteoporosis and a major cause of death, disability, and loss of independence in the elderly. Because as you grow old, people tend to, because calcium is very difficult actually to absorb. Even if you drink lots of milk, as you grow older, your digestive system will have a hard time actually absorbing most of the calcium. So that is also one of the reasons. And another reason why there's a loss of calcium, especially in women, it's because when pregnant women donate most of their calcium deposits to their babies. So that's why pregnant women need to drink a lot of calcium, or need to intake lots of calcium in their diet, because they are providing the calcium to form the bones of the baby in their womb. And that is why osteoporosis is very prevalent in women, especially the women who had born lots of children. So another condition called osteopenia occurs when there is a low bone density. So it is shown that regular exercise helps fight osteopenia and osteoporosis. Again, this has something to do with the principle in our body that if you utilize it more, the more they develop it. Just like how we build muscles. We build muscles by exercising. So if you use your muscles properly, or always use your muscle, that muscle tends to bulk up because it's always being utilized. The same goes for our brain. The more you use those particular brain cell, the more, our body won't degrade that part. Okay, so that's let's look now at the axial skeleton, the ribs, and the sternum. So we have the true ribs. They're called true ribs because they attach directly to the sternum. This is the bone at our chest. So and then you have the false ribs. They are attached to the costal cartilage, which connects to the costal cartilage of the rib. So they are false ribs because they are not directly attached to the sternum. So the sternum is the breastbone. So these are your the true ribs, because they are directly attached, but the false rib, they are not attached to your sternum. And then you have the floating ribs, not attached. The other side is not attached to anywhere. So your limbs comprise your appendicular skeleton. So the pectoral girdle, which are your shoulders, the upper appendages, the pelvic girdle, and the lower appendages. So this is your pectoral girdle. So you have your shoulder blades, the scapula, and of course the clavicle, and then the upper appendages. You have the humerus, the radius, and the ulna, and then you have the carpals. Carpals are the wrist bones, metacarpals in the hand, and of course the phalanges, our finger bones. And then in our pelvic girdle, this is the pelvic girdle. So you have your hip bone, you have your femur, the longest bone in the body, and then you have your tibia and fibula, your tarsals. So this is our basically the ankle bones, and then metatarsals and the phalanges again. So for the female and male pubic bone, the female pubic bone has a wider arc. That's why in archaeologies, for instance, or even in forensic anthropologies, how do you know if that skeleton is a man or a woman? Because again, we're looking at bones. You cannot actually use genital differences. So the way to know if it's a man or a woman is to look at the pelvic girdle. So if a wider pelvis, it's a woman. A shorter, a narrower hips, or a narrower pelvis is a man. Why? Because again, women bear children. So the child must be able to pass through this this pelvic arch or the pubic arch. Unlike for the men, of course, they don't bear children. Okay, so for the joints. So the joints exist whenever two bones meet. So they are classified by function or structure. In terms of functionality, we have several types. You have the immovable or synarthrotic joints. We have the slightly movable, the amphiarthrotic, and the freely movable, diarthrotic. So also called as the synovial joints. Now for the structural type, looking at it structurally, joints can also be classified into 4 types: the bony fusion, just like the skull, the fibrous, cartilaginous, and the synovial. So synovial is the most common type of joints for the freely movable. Why is it called synovial? Because it's movable. So it's like in a car, you need to have grease. You need to grease the parts of the car for them to function. You need to apply oil for the gears in the car to function properly. In the same way, the synovial joints must have are greased with synovial fluids. So because they are usually the ones that are moving, so they act as a fulcrum of a lever, allowing the force generated by a muscle to move alone. So those are the synovial joints. So looking closely at a synovial joint, so you have it's actually quite complex. So it contains a joint capsule containing the synovial fluid. So it's like the grease of the joint. So it also contains the tendons, the ligaments, the bursae, and menisci. So the bursae helps to absorb the shock and reduce friction. The menisci help to stabilize the joint and provide support. So for the knee, it contains internal ligaments, anterior and the posterior cruciate ligaments. So the more complex joint contains other accessory ligaments to help stabilize your joint. So the ligaments connect the bones together. The tendons connect the muscle to the bone. So for the movement, so the synovial joints are usually it's like again a fulcrum for a lever. So and it also provides lots of different structure. Actually, ball and socket joints are one of the most freely movable joints. But anyway, so you have the shoulder joints having the most movement, and it's a ball and socket joint. So that's why you have a large range. So it can rotate. It's actually had a very wide range of movements. For the hip joints, another ball and socket joint, but has less movements than the shoulder. For the hinge joint, you have the knee and the elbow. So extend or flex. So gliding joints they tend to move in a plane. So you have the saddle joints in our thumbs that allows the thumb to move across the palm of the hand. But we have hinge joints for the rest of our fingers. The thumb is the saddle joint. Now, our vertebrae are also it's actually also a joint, but it's more of a gliding one. So it allows a very limited movement, but we can bend down because it's basically several bones that are moving together as a team. Anyway, so skeletal muscles exercise power. So muscular tissue is a contract. Okay, now this is for the muscles. So actually we will discuss the muscles in the next part of this video.